Hello dear learner, welcome back to the Zoom Chemistry Hub. Today in this video we will discuss isomerism. So there are two types of isomerism, structural isomerism and stereoisomerism. Now we will discuss these two. Structural isomerism. Structural isomerism, in this type of isomerism, the isomers differ in the connectivity of an atom. That is, here we can see that is n-pentane and isopentane. They have the same number of carbon atom, but these carbon atom have different in connectivity. That is the straight chain alkane, that is the n-pentane, and this is an branch chain and it is called isopentane. Here the atoms are different in their connectivity. Next is the stereoisomerism. In the stereoisomerism, the atoms are connected in the same order but differ in spatial arrangement. That is, it means that the atoms have the same connectivity but they are different in their orientations. That is, they differ in their three-dimensional positions. That is, we have the example of cis-2-butene. Here this is the cis-2-butene. They have the same connectivity, that is the double bond are present at the same position, and in the trans-2-butene, here in these two structures you can see that the position of the double bond are the same, but here the arrangement of atoms or the connectivity of the group or the atoms are different. That is, this is the cis-2-butene and this is the trans-2-butene, in which the methyl group are in the cross form. So this is the trans-2-butene. Next we will discuss the types of structural isomerism. So there are 5 types of structural isomerism. The first is the chain isomerism. In the chain isomerism, the isomers differ in the arrangement of carbon chain. That is, we take the example of n-pentane, that is the straight chain. In this structure you can see that the parent chain are in a straight form, but in the isopentane have the same number of carbon atom but they are in branched. That is the isopentane. Here the one carbon is attached with the second carbon atom in the branch form. This is called isopentane. Next types of the structural isomerism is the position isomerism. In this types of isomerism, the functional group or the multiple bond is in the different position. As the name indicates, position isomerism. In the position isomerism, the functional group or the multiple bond have the different positions. That we have the example of 1-butene. Here you can see that the double bond are present with the one carbon atom, and 2-butene, here you can see the double bond are present at the second carbon atom or the number at the second carbon atom. Next types of structural isomerism is the functional group isomerism. In the functional group isomerism, the isomers have different functional group but same molecular formula. As the isomers which have the same molecular formula but different in their functional group, they are called functional group isomer or functional group isomerism. Here we take the example of ethanol. You can see that they have CH3CH2OH, that is the ethanol, and the ether CH3O and CH3. They both have the same molecular formula, but they have different functional group. Here is the functional group of alcohol and here is the functional group of ether. Next type of isomerism or structural isomerism is the metamerism. In the metamerism, the isomers have the same functional group but different alkyl group. In the metamerism, functional group are same but they have different alkyl group in their structure. For example, we have a methoxybutane. In this, you can see the one side of the oxygen is present methyl group and the other side of the oxygen group is the butane. So its name is methoxybutane. Here you can see the alkyl group are different in these two structures, that is the ethoxypropane. You can see that they have the same number of carbon atoms, same number of hydrogen atoms, they have the same molecular formula, but here you can see at the one side of the oxygen, that is the ethane, and the other side of the oxygen, that is the propane. So its name is ethoxypropane. Both methoxybutane and ethoxypropane have the same molecular formula, but they are different in their arrangement of alkyl group. Last type of isomerism is the tautomerism. In the tautomerism, they are formed by the proton migration from in the molecule. Here you can see that this is the keto form, this is a ketone, CH3 C double bond O and CH3, and when the proton are shifted and the bond are shifted from this oxygen to here, and here the proton are shifted from this carbon to an oxygen atom, they form enol form, that is the transfer of proton with the oxygen atom, and this is the enol form and this is the keto form. That's for all today, the learner. If you like this video, please like, subscribe and share with your friends and fellows. Thanks for watching.